Hi everyone and welcome back to our channel. In our earlier video we explained the Open RAN terminology. After that someone asked us to explain the different types of RAN architectures. In this video we will try to do this. Let's start with this picture we have used in some of our previous videos. During the 2G days and also in the earlier part of the 3G days, we used to have the cabinets at the bottom of the mast or tower that used to contain all the circuitry, hardware and software. The antennas used to be connected via RF cables. With the high data rates of 3G and 4G, the access network model changed to having the BBU in the cabinet and the RRU up on the tower. This way, the RF losses were kept to a minimum, as the connection between the BBU and RRU was fiber. Now in 4G, you would never see the traditional base station, but you can have an integrated base station. If we start with the high-level 4G mobile architecture, in practice the eNode B looks like this. There is a BBU or baseband unit and a radio unit or RU. In practice the RU is also called the RRU or RRH. RRU stands for Remote Radio Unit and RRH stands for Remote Radio Head. The reason it is referred to as remote is because it is on top of the tower. We can see an integrated and split base station here. In case of integrated units, all the layers and RU is part of the same package. This is often the case in the small cell architecture where everything is integrated in a single package. Of course, if you have seen our small cells tutorial, you will remember that there is a lot of confusion around the terminology sometimes. Before I forget, we call the connection between the RAN and the core as backhaul, and the connection between BBU and RU is known as the front haul. There is also different deployment options that need to be understood well. The first being the distributed RAN. This is the most common deployment approach today for 2G, 3G and 4G and even 5G. In this approach, the BBU is in the cabinet at the bottom of the mast or tower, and the RRUs and antennas are on the mast. An example of a rooftop site can be seen here. Here the RRHs are in the building on the roof and only the RF cable is run onto the mast. Here is a temporary site example. Here is the mast is thinner, it can't take the load of the RRHs, so they are at the bottom and the RF cable runs from them to the top of the mast. This is a long tower, so here the RRHs are up next to the antennas to avoid RF cable loss. The important thing to remember is that the DRAN allows all kinds of backhaul. We have a tutorial on backhaul if you want to learn more about backhaul types. The next deployment option is the Centralized RAN or CRAN, in which a group of BBUs are located in a single location called the BBU Hotel or BBU Hostel. The main reason for this approach is that in dense areas there may be no space for the cabinet next to the mast. One of the main challenges is that you would need to have a fiber, generally dark fiber, from the BBU Hostel to the site. The Centralized RAN approach would look something like this. While it is mandatory to have DAF fiber for front haul, the backhaul could be any type. This old presentation from Orange explains their approach towards CRAN. Step 1 and 2 is transitioning from traditional to contemporary base stations that we looked at in the start. Step 3 is the centralization of BBUs or BBU hosteling with stacking. Step 4 is the true centralization, which is achieved with resource pooling. To some extent, this can really be only efficiently done with cloudification of the RAN. As discussed in our earlier videos, the industry is in the process of transitioning from traditional physical network functions to virtualized and containerized network functions. While virtualization can help with resource pooling in CRAN, containerization is essential for going to a cloud-native architecture, which is a must for Cloud RAN. Cloud RAN is also called CRAN to confuse people. Earlier, most people would generally spell out Cloud RAN, but recently CRAN has started to mean Cloud RAN. Again, there is no hard and fast rule, it all depends on what anyone is talking about. An important point to remember here is that even if you have a completely virtualized or cloudified RAN solution, it doesn't mean that you have to deploy it as Cloud RAN. You can very well do a DRAN. The cabinet at the bottom of the site can contain a server with virtual BBU software. This also becomes important as Open RAN is generally a virtualized solution but is often deployed as DRAN. We can summarize the RAN architecture and deployment options as shown here. We often find people object to having VNFs or CNFs as DRAN, but that is how a lot of deployments are as of today. Notable exceptions being operators in China, Japan, South Korea, and a few other geographies. What is the main advantage of each of this topology? You might read many different things in publications, but they don't all apply in each scenario. Take DRAN. The main advantage is that the site is self-contained. You just need the backhaul to connect to the core. This means that you can have even backhaul with lower capacity and the site would still continue to perform. In contrast, CRAN requires dark fiber, ideally. So the location of the BBU has a limitation on how far it could be. So the BBU hostel or the cloud has to adhere to that distance. The main advantage of CRAN is that you require a very small footprint at the actual site because all the other servers, etc., are located in a central location or data center. This means that you need less capacity of battery backup and cooling on the actual site. With the DRAN sites, if there is an issue, only one site is affected. With CRAN, any issues can take out all the sites that it is serving. Let's look at a couple of views from the network equipment vendors. Before we jump into that, let us quickly review the 5G RAN functional splits. We looked at the 4G architecture earlier. The 5G architecture at a high level is similar to the 4G architecture. For 5G, the BBU is split into central unit, CU, and distributed unit, or DU. There are different splits possible that lead to different layers ending up in CU and DU. This can be seen clearly in this picture. While for 4G we have split 8 architecture, for 5G the popular options are split 8, 7.x, 2 and a combination of 2 and 7.x. So let us start with this picture from Samsung. Going from left to right, the first picture shows DRAN. As we move to CRAN, the basebands are centralized at edge cloud or edge data center. There is a gain with simplified radio operation and site leasing cost reduction. In this sense, CRAN is clearly a cost optimizer. The main challenge of CRAN, as we discussed, is the higher transport costs. As all baseband processing functions are moved to a central hub site, this creates a large amount of data overhead between radio and baseband. Thus, CRAN requires a very high capacity front-haul transport network, where you may need more fibers and efficient packet switching that supports stringent synchronization. To maintain the gain by centralized architecture, CRAN requires a front-haul solution that is economical and technically viable to remain as a cost optimizer. Samsung's view of vRAN is CRAN with virtualization. vRAN allows allocating resources in a flexible manner according to traffic conditions. Hence, there is resource pooling gain with vRAN. Finally, ORAN is RAN functional split 7.2 as defined by the ORAN Alliance. Finally, we have a slide from Nokia explaining the classic distributed and centralized approach that we saw before. They define vRAN with two different approaches. One approach that would be easier to do today is to have the RU and DU at the cell site and CU at the regional cloud. This would be RAN functional split 2. The second approach that they refer to as vRAN 2.0 is with complete disaggregation of RU, VDU and VCU. We think it will take a while before we see this approach commonly available. Here are some references for further reading. We hope we were able to do justice in explaining the different RAN architectures here in a simple way. There are so many other things and examples we could cover here, but most of them explain the same things in slightly different ways. Please feel free to leave any feedback, comments, questions, suggestions in the comment section below. Thank you for listening and hope to see you again soon. Goodbye.